Could you on the whiteboard show what the architecture of .NET is? That was one of my interview questions.
Was it really?
Yeah.
Wow.
Not for .NET, but for
somebody was
else.
mean. So yeah, of .NET itself, yes. Let's. What I'll show you is, kind of, something like .NET is actually pretty, pretty huge, right? And there's multiple different pieces to it.
That's the secret on your whiteboard, is it?
No, I don't think so. Might be code coming to a box near you. You never know. Basically, the way that we're sitting with the .NET framework itself, obviously at the lowest piece, and this is kind of like a layer cake diagram you'd see at the PDC, right? You get the operating system going across multiple dimensions, which for my team means 32-bit through x64, IA64 now with WIDB. The CLR piece that we're talking about is, this is the piece that I own, and that is a combination of things like this is where the garbage collector is, this is where we have exception handling, COM interop, it's the JIT, it's security, debugger, profiler, a lot of the engine kind of stuff you need to execute managed code. And a very high percentage of this code is written in a combination of assembler and unmanaged C++, because we had to bootstrap the engine itself. At the top of this, you wind up with the managed pieces of the CLR that we have. This is where the base class library and many, but not all, of the system.star namespaces for security and those sort of functionalities live. That's my team. After this, we of course have different pillars of other functionality. So we have, for example, web services. We're going to have the data stack out here. Let's see, you're going to have tools or environments like ASP.NET, et cetera. WinForms, obviously, for the client piece. All of these things sit on top of this, and these are all pure managed code, which is great. And then the other thing I would describe is that off here to the side, I'm going to have tools. And the tools, we own a couple of them. We own like the assembler and the disassembler, and again, a lot of the lower level signing tools, pieces like that. And then obviously this encompasses Visual Studio.NET. But this is the piece basically right here, and I guess with the C# and VB compiler. That's the piece that comes with Windows. That's the Redis. That's .NET FX that you're going to go pick up. Anytime you deploy it with your software, that's essentially what you're going to get. And then, this is basically a .NET framework picture. Of course, by the time we get off to talking about WinFX and the operating system pieces, or SQL Server, over here, basically you're going to have Yukon SQL Server. That also contains essentially a subset of this picture hosted in this environment. So I don't know if that's too high level, but
oh, that's pretty great. Where are the challenges for your team?
Oh boy, across the board. I mentioned things like performance, making this part small and working and having these guys run fast on top of us. In the WIDB release, for example, the biggest challenge we went after was VB RAD. So we did things like I didn't continue, which was a big feature ask that people have been looking for a long time. Amazingly complicated to go get right, and we finally have that nailed, so I'm very happy about that. We've also been trying to make it easier to write secure code with CAS, because I think that was a system that a lot of people were kind of confused by a little bit, and we needed to go figure that out. But again, performance, getting engine and things like that, done correctly. The debugger, big problem, the profiler, just you name it. Across the board. It's a big area of functionality within that kind of a box. You could basically spend your entire career, basically picking pieces in here and just kind of becoming an expert at it.
Do you have any questions about architecture? No, it's pretty clear. Tell us about the garbage collector.
Yes. Yeah.
Give us some secrets, some behind the scenes.
We actually have some fantastic documentation on the collector online. In fact, I think I have a link to it off of my blog, and it's a generational collector. And the interesting thing about it is there are actually multiple flavors of the collector inside of the engine. There is, for example, a client collector. That flavor is designed to give you better interaction with you. If you're dealing with a Windows environment, so that you're not like freezing up and you're like if you've ever ran Smalltalk or other collected environments in the past where they'd show you the little vacuum cleaner, while the collector was running. You don't have those problems. So that's one flavor. And then the server collector is actually quite sophisticated. It basically allocates a heap range per CPU and affinitizes allocations to it. It avoids bus locks because of that, so you get tremendous amount of great scalability. In addition to that, our collector is designed basically to directly manipulate all your pointers. There's no indirect handle tables or anything like that. I mean, there's a handle table for weak references, but the implementation is internal. So it's wired into the engine, and our JIT compiler knows how to register pointers to it and do stack traces on that and everything else. And that gets rid of, you know, the indirections associated with that. So it's basically a world-class allocator, and Patrick Dussude is our chief architect and the guy that wrote that. He's been doing this for 20 years, and he's just, you know, fantastic. So we really kicked butt there. Been very happy with it, and the interesting, you know, kind of like internally when we deal with Windows, SQL, you know, big groups like that. Of course, these are people that have been writing, you know, pure C, you know, systems level code. You know, it's got to be just great. When we talk to them about writing managed code, you know, same with Yukon, with SQL Server, the first question is always, how's that garbage collector going to screw me up? Right? Because just like writing an XML parser seems to be the thing du jour for every developer to want to go do, it used to be, you know, 15 years ago to write memory allocators, right? So there's no way your collector can be better than mine. And what's funny is after people have written managed code in that kind of environment, a year later, the collector's not even on the radar. And I've had a few try and go back and see if they could beat it. And the best they could do with their own custom allocator was very small micro benchmarks. They were able to beat that collector, not much beyond that. So interestingly enough, performance of the collector is not really one of the areas we see people getting bit. It's not the thing making WinForm slower, right? The thing making WinForm slower, when I talk about that problem, is we're running too much code, we get too many private pages and things like that. That's what we're tuning.
Now, the thing about the garbage collector, though, by default, in languages like C# is there's no notion of deterministic finalization. So you can't always be sure when your object will be destroyed.
Yes.
But in Manage C++, you can.
Yep.
So it's just a matter of language choice. The fact that Manage C++ was able to do it means that it's really not a CLR problem. Or, how they?
Yeah.
So let me ask you that. I take that back. How did they get around it?
Yeah, and so this one has always been kind of like a great canonical debate. In fact, I think that my former boss Brian Harry probably, you know, did like the Martin Luther thing and, you know, put the manifesto on garbage collection and deterministic finalization out on .NET, you know, like 4 or 5 years ago. It's a tricky problem because, you know, it's kind of like in some ways, you know, error handling. Like you've got to pick one or the other, and there's just certain things you live with. Usually the issue on deterministic finalization is when you have expensive resources. It's not cheap managed objects. Right? If I'm writing a dictionary thing that pulls something in and runs a sort routine and it's all just strings inside of the heap, don't worry about it, right? The collector is smart enough to, you know, understand memory pressure and get rid of it when it needs to. I mean, it gets rid of the garbage when you need to, and it's very good at that. The problem is if that managed object is wrapping an expensive unmanaged resource, right, like a window handle or a database connection or a socket or something like that, then there may be policy reasons why you want that thing returned to you quicker, right? I mean, I may literally be paying connect time on some kind of expensive operation. And so one of the things we introduced before we shipped was the dispose pattern to help with that problem in particular, right? And then we asked people to follow that pattern, and we gave you intrinsics to make that work. What the C++ guys have done for WIDBE, their deterministic finalization is not implemented in the engine per se. They have done a bunch of magic, very sophisticated work around the, you know, the vtables and you know, adding a destructor and things like that, which then use the intrinsics in the CLR that we have. The thing that we're going to have to see is when we get that implemented, what additional overhead does that system cause, because we don't have the support inside of the runtime itself. That'll be interesting to kind of see, because they've had to jump through some hoops in the IL in order to, you know, make the right kind of wiring happen, and that itself has some overhead. I would say that code, therefore, if you do an IL DASM against it, go take a look at it, right? See what the DASM looks like for you know, essentially the same code pattern with deterministic finalization in C++ versus the same thing in C# without it. And I think you'll find a difference in the code size, mostly because they didn't have a choice, right? We didn't give them, you know, that piece of code to do it. So it's kind of one of those philosophical, you know, debates, which one makes the most sense.
Well, and it also begs the question as why not have that built into the CLR to allow for deterministic finalization. I mean, on the one hand, certainly as developers, dealing with memory has never been a fun thing to do.
Yep.
But once you're good at it, you're very good at it, and you get used to it.
Yeah.
And so a lot of the things that people moving into managed code are complaining about, at least unmanaged developers, is this fact.
Yeah.
That they just have lost a little bit of control.
Mm-hmm.
And yes, they're more productive, but there's going to be certain cases, particularly with SQL Server, for example, where you want to be able to have maximum control over object lifetime.
Sure. Well,
so why wasn't that built? Just a question.
Mm-hmm.
Why wasn't that built in the CLR?
Yeah, we did look at doing it. The base answer is it causes a lot of additional overhead inside of the GC that runs counter to the way the thing is tuned, right? It causes extra tracking overhead that you have to go do, like, well, which objects get it? You have to put an attribute on it. Okay, when do you collect it, know that the lifetime is okay? Is it when the scope goes out, for a particular method? Do I now have to do, like what you do in C++, generate code at the epilogue that says, I'm leaving the function now, please clean up all my garbage? Okay, for which methods would you do that? So there's like a code gen piece that has to go in there. So it's not completely out of the range of doing it, but again, we've found that, like, using the dispose pattern and with like the using keyword in C+ and C#, you can kind of get around doing that. And what I found with like Avalon developers, for example, I mean, that's a big chunk of half of Avalon is written in C#, and that is a bunch of hardcore folks. Those are the same folks that brought you, in some cases, Internet Explorer and GDI and User, right? Those are the developers that wrote that code base. I really don't hear, deterministic finalization being the big issue for them. I do agree with you that people are kind of like in the mixed mode, like the IJW stuff. When you get to that point, then yeah, you're kind of in one world and out of another. If you have the luxury of being in the pure managed environment and writing your code just in C#, as an example, or pure managed C++, for example, then I think it kind of bites you less. You get used to the pattern, it works. And boy, having been a developer for a long time, not having to track down, dangling pointers and bit hoses in my process and stuff like that, like that commercial says, priceless. I mean, that just saves you so much time.
Especially while debugging.
Yes.
Tracking.
Yes. In fact, I've got some folks I want to introduce you guys to in a little bit that show you that sort of stuff. Because again, we're doing that we have to do that kind of stuff down here, right? Because we own tracking where all those pointers are. And we have, a class of bug called the GC hole, which basically means we forgot where a pointer looked like. We registered it, it got moved, it's a bit hose, right? And a lot of our stress amounts to us having to debug that kind of stuff. And boy, I'd much rather have my guys doing that than, a million programmers trying to figure out the same class of bugs.
Absolutely. Because in the .NET system, my app is sitting up here.
Yep.
And there's now another piece in between my app and the
Yep.
OS. Does that cause versioning problems, new kinds of versioning problems, or?
So I don't think that the
question
versioning
really is, where is .NET not appropriate, right? Where do you?
Yes. Yeah, there are some clear places, and honestly, there are a number of dimensions you should look at for being appropriate. You mentioned one, right, which is versioning, and versioning is a very hard problem. No vendor, no OS, no system in decades has figured out how to get that just right. It's a very hard problem. But there are other dimensions as well. I would say reliability is another one. So for example, if you were way down here in the operating system level and you have a user process that is designed to harden without exception handling being thrown, that's kind of like oil and water, right? So you got to be careful. That's why, for example, when you write a managed service, it goes into a separate process where you can handle that correctly. That's what Yukon does. That's what ASP.NET does. So that's one example of being appropriate or not. There's clear cases we just simply don't support. We do not expect you to be writing kernel code down here running at ring 0. Right? I mean, clearly that theoretically is possible, and in fact, there's some interesting research ideas about how one could use the IL to dynamically generate device drivers and stuff like that. I mean, there are interesting applications for that, but that's like a non-goal for us. We're not trying to make that sort of thing work. I think where we've proven incredibly useful is at the application level, where most code in the industry is written, and also on the web server with ASP.NET and pieces like that. And I hope that with the upcoming version also in the database for people getting rid of extended store procedures. There's another good example where I believe managed code will be far superior for people with XProx. Get rid of that stuff, right? Those are like the device drivers of SQL Server. Don't do it, right? So we're going to help you out there as well.
Interesting. So, yes. So the CLR is in that picture is where it should be. It should stay out of the OS.
Well,
at least for the next 10 years.
yeah, that's kind of our goal.
I mean a kernel when I say OS.
Yes, yeah, stay out of kernel mode. And in fact, for most people even working in Windows, they stay out of kernel mode, right? I mean, there's Dave Cutler and there's a few other guys, they know exactly what they're doing. You know, they do fantastic. But, you know, even most Windows developers don't want to really play around in kernel too much if they don't have to. And, you know, it's a good architectural purity thing to keep it small in the first place, right? So beyond that, like I said, there's dimensions, you know, there is versioning, reliability, you know, the hardening work, and a bunch of different dimensions like that you have to look at to decide where it makes sense. And for us, you know, my goal is not to immediately unleash managed code on every single piece. You know, I've got my plate full as it is, just, you know, doing the client, doing the server, doing the database, and, you know, operating system. At some point, maybe we'll be doing, you know, great big productivity application suites of, you know, major size. Who knows? But, you know, that's like a good long-term roadmap for us, and I think we can kind of build that up slowly and make people very happy along the way.
Are there any secrets of the CLR that most people don't know, or, you know?
Secrets, boy, you know.
What do you talk about with other devs at 2 in the morning over?
Yeah. Yeah, you know, we try. So the interesting thing about the CLR is, you know, I think I like to kind of describe us like Switzerland, right? I mean, our job is to provide this platform environment which makes, you know, developers very successful. And one way for us to do that is to be very open, right? So we try not to have secrets by design. The C is for common, right? So for the first thing we do is we have standardized with ECMA, you know, the CLI and the CLS, and we want other vendors, and we've got other vendors using the stuff in production, so you can't be, you know, too closed on that. I've got my rotor book, you know, right over there on the shelf. We have all of the source code for the CLR rotor academic version, the little thin blue one there next to the ship it plaque by Addison Wesley. That's Jeff Schilling's book. But that CD there comes with, you know, like, you know, 75–80% of the source code that is the CLR. It's the same source code. In fact, in our, you know, we have an automated check-in system. One of the builds that every check-in goes through to make sure that it can actually be applied to the depot is a rotor build, you know, running with you know, a non-Microsoft compiler, just to make sure that we can keep doing that. So from that perspective, we're actually quite open and transparent for the stuff that we do. So if you want, you know, a secret, a little gloating, my initial is in the signature for the metadata. So if you look at that, you know, for like an inside tidbit thing, Brian, Harry, myself.
Is that considered an Easter egg? I didn't think you.
You know, I don't think so. You know, Mark Zibikowski is, you know, if you look at the PE header, it's MZ. That's Mark Zibikowski, who's a, you know, developer that was around when they kicked off the first file format. So we thought, hey, why not? So, you know, the initials in there are myself, Brian, Harry, Susan Racky-Sproul, and Bill Evans. The four initials in there. That's about as close to a secret as I think I can get. It's undocumented at least, but yeah, that's about it.
So one of the questions that a lot of customers have is, what product group at Microsoft has really just adopted managed code going forward?
Yes. Yeah, so for hardcore adoption, I mean, there's a number of them, obviously. The web server with ASP.NET is the most obvious and the one that, you know, all of us are kind of using on a daily basis. After that, we've got, you know, a combination of a couple of things. There are people that are using managed code to write new applications they're doing. We have an IT staff, just like every big major corporation, and, you know, almost all of our new stuff is being written exactly that same sort of way. And I mentioned a couple of those LOB apps already. And then the next big camp that we have is big hosts that are hosting the CLR and allowing other developers to plug into it. That's where you've got SQL Server. That's where I expect the operating system to be. You can expect that kind of trend, you know, to continue, because it just makes your life that much better. In terms of big applications, there's some ISVs. Like I said, there's some companies that release peripherals like scanners and printers and things like that, that when you go off and pick up that digital imaging CD on there, that's written with managed code. So we've got other big ISVs writing, you know, rich app like that.
Graphics cards.
That's right. ATI just released the graphics card config thing, so every ATI card comes out with it. And, you know, basically at this point, when you buy a new computer, you know, from your favorite OEM, it's going to come pre-installed with the .NET framework, right? It's just there. And of course, you know, WSO3 has it installed by default as well. So that's another, you asked for challenges before, that's another challenge, is kind of getting a framework like this distributed where developers can target it, you know, and easy and feel good about writing software. In fact, I'm in Outlook. I'm running Lookout, which is a great little application for indexing my hard drive and in my inbox. That's also managed code running inside of Outlook. Pretty cool app.